My presentation is entitled A Statistical Treatment of the Solomon Four-Group Design, a Meta-Analytic Approach by Braver and Graver, 1988. The Solomon Four-Group Design is seriously underutilized. A major issue was how to combine an analysis of the effect of the treatment in the post-test only groups with the same effect in the pre-test and post-test groups, and to do so after an earlier phase of the analysis had shown no effect or no evidence of pre-test sensitization. So this is why this design came about. Now, this design adequately controls for threats to internal validity. Other designs that it's compared to are a pre- and post-test control group and a post-test only control group. Now, the most notable difference of the Solomon Four-Group design is that it assesses the presence of pre-test sensitization. That is, it controls for the administration of a pre-test by exposing four groups of subjects to different conditions. Helmstadter 1970 said it was the most desirable of all the basic experimental designs. Despite this, there are four major reasons for its underuse. It requires twice as many subjects, first off. If you're comparing a pre-test to post-test, you only need the conditions to differ in the fact that one gets treatment. Here you would need one for pre-test, without pre-test, one of which would get treatment, and then also both without pre-test and one of those groups getting treatment. Number two, many investigators claim not to be interested in pre-test sensitization in itself, so they would argue that using the Solomon Four-Group design is only for those interested in a specific research question regarding pre-test sensitization. However, any design using a pre-test and post-test could be affected by pre-test sensitization. Therefore, this design would adequately control for that concern. Number three, conclusions become increasingly complicated due to a number of conditions. The complexity of the phenomenon is no reason for science to exclude its use, however. Just because the conclusions become complicated due to the number of conditions, it's no reason to discount its use. The largest reason, however, is a lack of certainty concerning the proper statistical treatment of the design, and that is the focus of the following paper. Just a brief overview of the design. There are four groups, and all are randomized. Two of those receive a pre-test, one of those would receive treatment, and both receive post-test. The other two do not receive a pre-test, one of those receives treatment, and both of those receive post-test. Therefore, this design controls for the effects of a pre-test on both treatment and control conditions. And that's something that other designs do not control for. Other reasons for using the Solomon Four-Group design versus other designs. Post-test only control groups could have had differences in the beginning that are not shown. Therefore, the effect of treatment remains unknown. Controls for pre-test, but without comparison, there is less utility. If the differences exist that would have been shown in a pre-test, the post-test only groups may appear to show a difference due to treatment when actually they were a pre-existing difference that went unmeasured. Also, pre-test, post-test designs can result in repeated testing effects, fatigue, sensitization, and interaction effects. Repeated testing combined with the treatment, which could be a very big concern that's alleviated through the Solomon Four-Group design. And again, this design controls for these issues by assigning to groups that balance all of the concerns. So if you consider the first condition to be a pre-test, treatment, post-test group, then you will be able to make comparisons to a pre-test, no treatment, post-test group, a treatment, post-test group, and a post-test only group. No other design allows you to do this. And this is a huge advantage when the arrangement of any of these conditions can have an effect. So, considering that the biggest concern is how to analyze this complex design, Braver and Braver developed a flowchart to show how to use statistics to make decisions based on the results from a Solomon Four-Group design. So their flowchart is very complicated and hard to describe verbally. I suggest looking at the article for more information. But first, you would perform a 2x2 ANOVA on the data that you receive from the study, and if the interaction is significant, you perform a simple main effect test on pre-tested groups, and then on post-test only groups. If significant, you conclude treatment has an effect on all groups, even those without a pretest. And obviously, if it's not significant, then you conclude the treatment does not have an effect. If the interaction is not significant, you perform a main effect test on experimental versus control effect, and then it continues to go down this line. And as it gets more complicated, it eventually reaches into where a meta-analysis of the data is required to examine actual treatment effects. So, however, this study did not collect any real data. They did examine the ability of the Solomon 4 group design through a meta-analysis to detect significant differences that other designs would fail to capture. So the data they used showed that other designs do not control for variables of interest that are easily contained through the use of this design. And in the author's words, when they're summarizing how the meta-analysis was used to examine this hypothetical data, they said, "The power of the meta-analytic technique is revealed in that none of the customary analyses reached significance, but the meta-analysis did. Thus, when the data conformed completely to the pattern predicted by a treatment effect, uncontaminated by pretest sensitization, only the meta-analysis reached significance in detecting that fact." So while an earlier concern about this design revealed that it requires twice as many subjects, the authors suggest that even splitting the number of subjects per group in half will take care of this. They say there's no loss of power in the design by doing this, and in fact there's generally a slight gain in power, especially when compared to the post-test only design. So that is, you can still properly analyze the effects of pre-test, treatment, and post-test all under adequate controls. So in conclusion, the only objection the authors accept is the difficulty in running subjects both with and without pre-tests. However, this objection is more than compensated by the Solomon design's advantage in providing information concerning the external validity of the treatment effect. So again, to reiterate an earlier statement, we should not avoid using powerful techniques simply because of an increase in response effort.